Hi guys, so we are on, believe it or not, the last lesson that we're going to do this year, and it is graphing rational functions. So we're putting it all together. We've learned how to find the domain, vertical asymptotes, holes, horizontal asymptotes or oblique asymptotes, y-intercepts, x-intercepts. We've learned how to find all of that, and now we're going to put that all together in the graph form. So we find all that information, we put it together on a graph, and that's what today's lesson is all about. So we're combining the last 4 weeks worth of stuff into one. So here we go. We're going to show you how to do this. I'm going to do 4 problems. You're going to do 4 problems. There'll be a short Delta Math assignment, and that will be it, guys. And then yeah. So there we go. So we're going to work through this just like what we did on the part. So we're going to find the domain first. So I'm going to take my function. What I'm going to do first, what I like to do first, is I'm going to factor my equation. I always like to factor my equation because it makes it easier. So there's nothing on the top to do, so my numerator stays the same. By denominator, I can factor. I need 2 numbers that multiply to be -6 and add to be 1. Well, I think that is 3 and -2. So that factors to x plus 3 times x minus 2. Okay, so and after I factored my equation, both the numerator and denominator, in this case I can't do anything with the numerator, I'm going to find my domain. And that means I set my, like it says here, I set my denominator equal to 0. Okay, and your problems are going to be just like this. I'm going to upload them to into the program. So sorry, upload them into the program one problem at a time, and then or just one sheet at a time, and then you'll graph it as a draw it problem. So here we go. We're going to find the denominator. Find the domain. Whew, I'm doing good. So I'm going to take my denominator, which says x plus 3 times x minus 2, and I'm going to set it equal to 0. So that means I have 2 things multiplied together. That means one of those things has to be 0. So that either means that x plus 3 equals 0 or x minus 2 equals 0. So if that's true, that means that x is going to equal -3 and x equals 2. Okay, so now that we have that part done, I'm going to write my domain. And I noticed some of you guys were saying all real numbers except for those 2. We really need to write it. We can write it that way, but for those of you going to calculus, you really need to write it this way. And actually a lot of you were writing it -infinity to -3, right? We go from least to greatest, joined with -3 to 2, and none of these are included, joined with 2 to infinity. So there's my domain. Okay, so now the next one, vertical asymptotes, is pretty easy once we've done the domain, because my vertical asymptote goes with my domain. Well, I have a vertical asymptote. I don't have anything that crossed out, so I don't have any holes. Let's go there first. Since I didn't have anything that canceled out in my equation, I have no holes, none. Okay, so I do have vertical asymptotes where my domain, where my x's are in my domain. So I do want to just remember on my domain, x cannot be -3 and it cannot be 2, because that's where it makes the denominator 0 at. So my vertical asymptotes would be at x equals -3 and x equals 2. Okay, so I have 2 vertical asymptotes. And remember, a vertical asymptote, a line can approach but not cross. So now we're going to look at my oblique or horizontal asymptotes, or slant or horizontal asymptotes. And I am going to recopy my equation down here. My equation is f of x equals 1 over x squared plus x minus 6. And when I'm doing this, I want to find my degree. So my degree is here and here. So the degree in my in my numerator, degree, equals 0, because I have no variables in the numerator. And the degree of my denominator is 2. And we know that 0 is less than 2, and that means that n is less than m. So that's case 1. If you remember from last time, we had 3 cases where n is less than m, n equals m, and n is greater than m. And when n is less than m, my horizontal asymptote is y equals 0. So I have a asymptote at y equals 0. Okay, and now I want to find my y-intercept. Well, how do I find my y-intercept? Well, I set x equal to 0. So I'm going to find f of 0. That means wherever there's an x in my equation, I'm going to put 0. So I've got 1 over 0 squared plus 0 minus 6, which is 1 over negative 6. So I've got a y-intercept at 0, negative 1/6. Okay, and then the next thing I need to do is find my x-intercept. So my x-intercept is where y equals 0, where f of x, I just want to kind of highlight this part, sorry, where I set y equal to 0. Okay, so that means that 0 is going to equal 1 over x squared plus x minus 6. Let me rewrite that one right there. Okay, x squared. So if I turn this into a fraction and I cross multiply, I get 1 equals 0, because 0 times anything is 0. So that's cannot be possible. 1 cannot equal 0. So that means for my x-intercept, because that is impossible, I have none. There's no x-intercepts. Okay, great. So now on this graphic organizer we have for this, it says I have to find other points if needed and to graph it. So I'm going to show you how I decide which other points to pick, and I am going to pick some. So I'm going to draw a little table here. Whew. I don't know how many little slots I'm going to need. We'll just leave it there. So I'm going to draw in all my information I just found. Okay, all the information I found. I found a vertical asymptote at x equals negative 3, and asymptotes are drawn in with a dotted line. So I've got one asymptote there, and I've got one at 2. So I've got one there. And then I've got a horizontal asymptote at 0, y equals 0. So that is also dotted. Okay, and then I have a y-intercept at 0, negative 1/6. I'm going to do that in my points I'm going to do in a different color. So it's probably closer to the line than that, but you know, we're sketching here. So 0, 1, 6, and I don't have any x-intercepts. So there we go. So I'm actually going to need some more points to tell me where on my graph to put stuff. So I'm going to choose values for x and substitute them for f of x. And remember, my equation is f of x equals 1 over x squared plus x minus 6. And I can just put that right into my calculator. Remember, if I'm going to put that in my calculator, this needs to go into parentheses. Okay, so you can get the correct answer. So here we go. How do I decide which values to plug in? So I need one, and I'm going to turn this into a highlighter here. I need one on this side of my asymptote. So I need to know what's happening on this side of my asymptote. I need to know what's happening on this side of 0 and on this side of 0. And I need to know what's happening on this side of my asymptote. So I need 4 different points. So I need 4 values. So I'm just going to pick an x value. So for this one, I'm going to choose negative 4. And then in this area over here, this area here, so in this area I chose -4. In this area I'm going to choose -2. And in this area I'm going to choose 1. And in this area I'm going to choose 3. I just chose the closest ones to the asymptotes just to make it a little easier, okay? And then for the -2 and 1, I just chose the ones closest to the asymptote because that kind of gives me an idea of the shape of it. So I'm just going to plug -4 in. So in my calculator, plug it in, and I get a value of 0.17. And I plug -2 in, and I'm going to get a value of -0.25. And if you don't trust me, go ahead and pause the video and go ahead and plug your values in and see what you get. And then I get a value of -0.25. 0.17. Okay, so let's go ahead and plot those points. So -4.17. So that tells me what my graph is going to look like on this side. It's going to go like this along here, and then it's going to go shoot up, and it's going to be like this because it's not going to cross the asymptote. So it looks like this. And then I'm going to go ahead and graph the end one. So at 3, it's also at 0.175. So it's going to do the same thing. Okay. So here we go. There we go. Okay. And then we want to graph my other 2 points. So -2, -0.25. So I'm somewhere in there. And -1, -0.25, somewhere in there. So everything here is in the lower quadrant. So we're going to go up, over, it's kind of flattish, and back down. So it kind of looks like that. So that's what the graph looks like. Now, if you want to check yourself, you can go ahead into Desmos and go ahead and check it. And you put it into Desmos the same way that I put it here. 1 divided by parenthesis x squared plus x minus 6. So put that into Desmos that way, and you should get this graph into various graphing calculators. It should be very similar to the same thing. Okay, so we're going to go ahead and go to the next one. Notice, I'm sorry that it's taken a while. I want to make sure that you guys get how to do this. So this video is going to be a little bit longer. I apologize for that since we have 4 problems to do. So here we go on to the next one. I will go a little faster through this one. I wanted to go a little slower for the first one. So here we go on the second one. Here's my equation. Notice we did not change the denominator. We just changed the numerator a little bit so you can see what happens to the graph as we change the numerator. So my domain, still the same thing. So I'm still going to factor it. And since I know that my denominator is the same, it is still x plus 3 times x minus 2. So I left the denominator the same. So I set it equal to 0. So I've got x plus 3 times x minus 2 equals 0. So x plus 3 equals 0 and x minus 2 equals 0. So x equals -3 and x equals 2, or rather they can't equal that because that's what makes the denominator 0. So my domain would be -infinity to -3 joined with -3 to 2 joined with 2 to infinity. Okay, great. And my vertical asymptotes. So I did not cancel anything out again, so I have no holes. So I'm going to say holes, none. And my vertical asymptotes, I kind of found out from my domain. There are x equals -3. They're whatever, my vertical asymptotes are what makes my denominator 0. So there's 2 of them. X equals -3 and x equals 2. Okay, so now we get a little harder because I need to find my horizontal asymptotes. Those are a little harder, so I'm going to rewrite my equation. F of x equals x plus 1 over x plus 3 times x minus 2. Okay. Sorry, I should have written the unfactored version of that. So sorry. X squared plus x minus 6. Okay, so I need the degree, and the degree of my numerator, degree, is 1, and the degree of my denominator is 2, and 1 is less than 2, so that means n is less than m, so this is still case 1. So my horizontal asymptote is y equals 0. Okay? Still the same there. My y-intercept, so I'm going to find f of 0, so I've got 0 plus 1 all over 0 squared plus 0 minus 6. So that is going to equal 1 over negative 6. So my y-intercept is 0 comma negative 1/6. Okay, good job. Now we want to find the x-intercept. So I'm going to set 0 equal to x plus 1 over x squared plus 0 minus 6. I'm going to cross multiply, and I get 1 times x plus 1 equals 0 times x squared plus x minus 6, which I totally wrote wrong. So I get x plus 1 equals 0, or x equals 1. So my x-intercept is going to be 1, 0. Okay, so now we're going to make a table, because we don't, and since I don't know how many extras I'm going to have to choose. Probably won't choose more than 4, just so you guys know. X and f of x. And I'm going to go ahead and put in my information here. So I know that I have, let's see, what do I have? I have a vertical asymptote at -3. And I have a vertical asymptote at 2. And I have a horizontal asymptote at 0. Okay, so there's my asymptotes. I'm going to put my points in with a different color. So my y-intercept is at 0, negative 1/6 again. Okay, and then I have an x-intercept at, oh, did I do something wrong? I think I did really quick. Oh, it's not x equals 1, it's x equals -1. Whew. Okay, so sorry about that. So -1, 0. Remember we said when we were talking about horizontal asymptotes that my graph could cross a horizontal asymptote, it just cannot cross a vertical asymptote. And so there we go. So now we need to choose values again to find out, to find other points, to find out what my graph is doing. So I'm going to choose one in this area, and I'm going to choose one in this area, and I'm going to choose one in this area, and I'm going to choose one in this area. Okay, so here we go. I'm going to choose -4 again. Again, I'm going to choose as close to the asymptote as I can. I'm going to choose -2, and we just choose 1, and I'm going to choose 3. And I'm going to plug it into the calculator. Well, what is my equation again? Well, it's f of x equals x plus 1 all over x squared plus x minus 6. And when I'm putting it in to the calculator or to Desmos, make sure that I'm putting parentheses around my information so that the right things are together. So if I plug in -4, I am going to get -0.5. And if I plug in -2, I'm going to get 0.25. And if I plug in 1, I'm going to get -0.5. And if I plug in 3, I'm going to get 0.67. Okay, so now I'm going to graph these points. So I've got -4, -0.5, so that's underneath. And it's going to look like this. And if I plug in my other points here, 2, 0.25, and 1, -5. Okay, it's going to kind of snake around here. So it kind of looks like this. There we go. And 3 2/3 about there. So it's coming like this. Okay, there we go. There's the function for this graph. Good job, you guys. Picked up the pace a little bit. That's good. 2 more graphs, and we're going to show you what they look like. The next one still has the same denominator. So here we go. Same denominator. Again, you can check the graphs, putting it in your graphing calculator, which I would do. So I'm going to factor the my equation again. This time I have x plus 3 all over x plus 3 times x minus 2. So to find my find my domain, I set the denominator equal to 0. So I've got x plus 3 times x minus 2 equal to 0, or rather it cannot equal 0, right? So I have x plus 3 cannot equal 0, and x minus 2 cannot equal 0, so I get x cannot equal -3, and x cannot equal 2. So my domain is going to be from -infinity to -3, joined with -3 to 2, joined with 2 to infinity. Okay, great. Vertical asymptotes. So now I'm going to look at my equation. I'm going to bring it over here. So my equation says f of x equals x plus 3 all over x plus 3 times x minus 2. Well, I can cancel something out, right? I can cancel that out. So that makes my equation equal to 1 over x minus 2. So this time I do have a hole. I have a hole at x equals 3. So I have to find the y value for that, and we're going to do that in just a minute after I talk about the vertical asymptote. My vertical asymptote is my other one. What's going to make my denominator 0 now? Well, x equals 2. So I have one vertical asymptote and one hole here. How do I know where my hole is now? So I know the x coordinate of my hole is at 3. X equals 3. And now I need to find the y coordinate of that. Well, it's pretty easy. I'm going to take this value, I'm going to take my 3, and I'm going to plug it into my equation. And you can plug it into either equation, either the original one or the simplified one. I like plugging it into the simplified one just because there's less work. It's easier, right? I mean, honestly, it's a little easier to find. And I'm sorry, it's should be -3, not +3. So here we go. So I'm going to just find f of -3. So I have 1 over -3 minus 2, which equals 1 over -5. So I have a hole at -3, -1/5. Okay? And then we're going to go on to the next one, which is my oblique one. Okay? And I'm going to use my original equation. So I've got x plus 3, f of x equals x plus 3 over x squared plus x minus 6. And again, my degrees here. Okay, so degree of my numerator is 1, degree of my denominator is 2, and 1 is less than 2. So that means n is less than m. So this is also case 1. So my horizontal asymptote is y equals 0. Okay, so now we're going to find my y-intercept. My y-intercept, I'm going to find f of 0. And that means that I'm going to plug it in. And again, I can plug it into either equation. I can plug it into the original equation, or I can plug it into my simplified equation. It's going to give me the same answer. So I always like plugging it into my simplified equation because I don't have to simplify later. That's just my, that's how I like to do it. So I've got 1 over 0 minus 2, which equals 1 over negative 2. So my y-intercept should be at 0, negative 1/2. Okay, great. And now I'm going to find my x-intercept. Again, I can use either equation, and I'm going to use my simplified one. So I've got 1 over x minus 2 equals 0, cross multiply, and I get 0 equals 1. So for my x-intercept, there are none. There's no x-intercepts because 0 cannot equal 1. Okay, good job, you guys. And now we are going to graph. We're going to graph all the little bits that we have and see if there's any extra points I need to find. Okay, so what do I know? Well, I know that I have a vertical asymptote at 2. So I have a vertical asymptote here. And I know I have a horizontal asymptote here. And I know I have a hole at -3, -1/5. So I have a hole, and technically it's just a hole. It's a hole. It's a hole. It's a circle. It's a hole in the graph. You guys know what holes in the graphs are. It's an open circle, okay? It means there's nothing there, okay? And then I have my y-intercept at 0, -1/2. Okay, 0, -1/2 is here. And then I have no x-intercepts. Okay, great. So I think I have all my points there. So now I'm going to find, how do I decide here where I want my points at? Well, I know that I want one from here over, from my hole over. And then I want one between my hole and 0, and one between 0 and my asymptote, and one here. So I want to find each one of those points. So luckily, I'm still going to just use the same numbers that I've been using, -4, -2, 1, and 3. Okay, so we're just going to plug it in, and again, you can plug it into either one of them, but I'm going to write the original equation down so you can put it into there. So it's x plus 3 all over x squared plus x plus 6. And if you're going to put it into the calculator or into a graphing calculator, make sure that the parentheses are around it. Okay, into Desmos, make sure the parentheses are around it. So here we go. I put it in there. My points are -0.17, -0.25, -1, and 1. So -4, -0.17, okay, -1, -1. Oh, 1, -1. Woo, helps if I read my things right? And 3, +1. Okay, so that means this graph, the graph on this side, is going to kind of look like this. Go to my hole, stop, pick up on the other side. So that's all a hole is. It's a hole in the line. It just stops in the middle of the line. So there's the hole. Okay, and the other one just looks like this with no holes. It just goes through the point. Now, most of your graphing calculators, I want to say, in fact, I haven't seen a graph calculator yet that will actually put the hole in the graph. So if you have a hole in your graph, and I have not found a graphing calculator that will actually put the hole in the graph for you. So you need to be aware of that fact. So I just wanted to throw that out at you. One more. This one should be fairly fast also. And then you guys are going to try this on your own. Notice it's not that, I don't want to say it's not that hard. It's just taking all the pieces that we've done individually and throwing them together in one piece, okay? So try not to freak out too much, okay? So here we go. I'm going to factor, and I'm going to factor the top first, or my numerator. So I need two numbers that multiply to be -15 and add to be -2. Pretty sure that's -5 and 3. So my numerator factors to x minus 5 times x plus 3 all over x minus 5. Okay, great. So for the domain, I need to set my denominator equal to 0. So I've got x minus 5 equals 0, or doesn't equal 0, can't equal 0. So x cannot equal 5. So my domain would be from negative infinity to 5, joined with 5 to infinity. Okay. Domain's a little easier when there's only one number that the denominator can't be. Okay. So now we're going to talk about the vertical asymptote. So my vertical asymptote, f of x is going to equals x minus 5 times x plus 3 all over x minus 5. And we have a cancellation. So with that cancellation, I don't have anything in the denominator, so my vertical asymptote is none. I have no vertical asymptotes. But I do have a whole, and my whole is at x equals 5. So now I'm going to plug it in and see what I get, right? So I want to plug it in, and I can either plug it into my simplified equation, which happens to be x plus 3, or I can plug it into the regular equation. Plugging in the simplified one is a little easier. It's 8. So I have a whole at 5, 8. And now we want to find the horizontal or oblique asymptote. So I've got f of x equals x squared minus 2x minus 15 all over x minus 5. And we've got my degrees. So the degree in my numerator is 2, and the degree in the denominator is 1. So I know that 2 is greater than 1, so n is greater than m. So this is case 3. Case 3 says for horizontal asymptotes there are none. When n is greater than m, there is none. But I have a slant that tells me I have a slant asymptote. And to find my slant asymptote, I actually have to do synthetic division if I can. And in this case, I can. So I need the coefficients of my numerator, which are 1, negative 2, and negative 15. And then I want to divide by what it cannot be in the denominator, which is 5. So I bring the 1 down, it's 1. 1 times 5 is 5. Add it together, I get 3. 3 times 5 is 15, and that's a 0. So my slant asymptote is y equals x plus 3. Okay? All right. So here we go on to the next one, which is the y-intercept. Y-intercept, I'm going to do f of 0, and I'm going to put it into my simplified one, which is 0 plus 3, which is 3. So my y-intercept is 0, 3. Okay? And for my x-intercept, I get 0 equals x plus 3. So subtract 3, right? So x is going to equal negative 3. So for my x-intercept, I did the same color, oh well. X-intercept is negative 3, 0. Okay? So here we go. In case I need some other points here. So I've got, let's see, what do I have? I have no vertical asymptote, but I have a whole slant asymptote at x plus 3. So start at 3. Ooh, that was a straight line, sorry. Just drawing my slant asymptote here. Okay. Great. I have a y-intercept, so now we're going to start putting in points. So x, f of x So I have a hole. Where was my hole at? 5, 8. So 5, 8. I have a hole here. Okay, I have a y-intercept at 0, 3. I have an x-intercept at -3, 0. So I'm going to just pick a few points here. -4, which gives me -1. -2, which gives me 1. 1, which gives me 4. Let's see what that does. Gives me a point here. -2, 1 gives me a point here. 4, 1, 4 gives me a point here. Oh, it looks like my graph of this is a straight line that is my horizontal asymptote, my slant asymptote. And there we go. That's it. So please make sure you're asking questions and using your graphing calculator or Desmos on this. It will work for you. Make sure you're asking questions. Okay, you'll have 4 graphs just like this to do. Sorry this video was the longest one. It is the last one though, so it's apropos that it is the longest one. Thanks guys. Make sure you're asking questions and getting all your work done before the end of the year. Thanks guys. Have a great day. Bye.